My name is Scott, and we're going to talk today about an Amazon service called Step Functions. So before I get started, I want to give a quick shout out to Yelp, my company. They were kind enough to send me down here to talk to you all today, and I appreciate that. If you don't know, Yelp is really focused on local businesses. So we're sort of around to help you find what you're looking for, whatever city you happen to be in. And I work at Yelp on the revenue or commerce side of the company. So essentially, when you buy something on Yelp, and you can buy food delivery, you can buy restaurant reservations, advertising contracts if you're a business owner, a lot of different stuff. All of those different products you're purchasing come through a set of teams that I work with. And we're sort of responsible for doing things like processing payments, making sure we get the right amount of money at the right time from people who owe it to us, and that we pay out money that we owe to other people. And if you're inclined toward Twitter, you can find me at Scott Triglia. You'll see it plastered all across the slides, so it's pretty hard to miss. All right. So I want to start us off with a little bit of audience participation, and this is mostly for my sake to get an idea of where you all are coming from. Raise of hands, who has heard of step functions in any form? Who is like vaguely aware of the term? All right. So we're maybe working with like 20%. Who has actually used step functions in any project of any kind? All right. Very few people. Who's heard of Lambda, Amazon Lambda, serverless? Okay, a lot of people, 50%. And who's actually used Lambda? Okay, back down to a small number. Cool. So this more or less matches my own experience and what I've heard from other people, which is a lot of people are hearing terms like Lambda in particular, serverless. Maybe you're hearing something like step functions, but the number of people who are actually using them, who get to use them in whatever you all do day to day, is much fewer. And they're sort of something you hear about and then don't get to put into practice. And my goal for today is to kind of talk about that. So from my perspective, it can often feel like these new cool technologies, things like step functions, things like Lambda, are really fancy things you hear about when you go to a Python conference or something like that, but they're not things you get to put into practice. They're things you hear about other people talk about. And for me, this kind of reminds me, because I'm a huge sci-fi geek and I really enjoy this sort of stuff, of a movie from a few years back called Elysium. And just to give you a quick primer in case you didn't see it, there's essentially a future world where there are the haves, the rich people that get all the good stuff, and the rest of the have-nots that don't. And the haves literally live in space on a cool space station. Kind of looks something like this. It's sort of a resort feel to it, maybe a country club. Very nice, very green and lush. And everyone else lives down on something that looks a little more like this on Earth in these large slums. And so the difference between the haves and the have-nots is literally the difference between Earth and space, right? They're as maximally distant as possible, inaccessible, and the cool things that you might want are sort of unobtainable in that way. And sometimes, when I'm feeling a little negative or dramatic, it can feel like this is the difference between what I hear about when it comes to cool technologies like serverless and my day-to-day life, right? Serverless is sitting up here in the country club somewhere. I can't even see it. It's off in space, and I don't get to use it in the projects I want to, even though it sounds really cool. And I'm, dealing with whatever my day-to-day problems look like. Hopefully not nearly this bad, but it's really not possible for me to reach out and have this future that I've been told about. So our goals today are to talk about step functions. You'll hear me using SFN as an abbreviation for it quite a bit. And kind of talk about why we chose it at Yelp, how it gets us closer to this space-age future, and give a little sense of that kind of progression from wherever you may be today to how you can get access to things like Lambdas by using step functions. And to do that, I'm going to talk about subscription billing. So I said my team works with products you purchase, and if you're purchasing kind of a recurring product, ads is one of the main ones that we do at Yelp, but anything that you pay for every single month, you need to have a tracking process. And every month, you're going to need to come through and get people to figure out how much they owe and pay it. So this is our subscription billing process at Yelp, and it's really, really important. So this has been around for roughly as long as Yelp has been a company, because we've had subscription products that whole time. And essentially, if it stops working, nothing good will happen, right? If I go in there and I try and make a fancy modification to the system and I break it, I will be hearing from the CEO, from the most important people of the company saying, hey, Scott, it's nice that you wanted to do some engineering project, but you need to turn back on the thing that makes all of the company's revenue. So really critical stuff, really old stuff. It's a decade old. And it happens at a pretty large scale. So we work with over 100,000 accounts. And it works roughly in the middle of a three-part process. So we start by figuring out what accounts we need to bill. We roll up invoices, receipts. We're basically deciding what we need to get paid for. And then we collect money, 1, 2, 3. And this is happening every night across all these accounts. So we talked to ourselves and we said we kind of want to make this system a lot better. We want to improve it. We want to dig out from 10 years of sort of maintenance costs and burdens. And we had a couple challenges there. We had heard about interesting serverless technologies like Lambda. We had heard about Amazon's API gateway. Of course, we had our own ideas about maybe microservices or other sort of engineering goals that we wanted to put into practice. But doing any of these was really hard, expensive, and frankly, dangerous. There wasn't really any API for this business practice. It was essentially a job that ran nightly, did something, and if you never touched it, it kept doing the same something, and the company makes money. So API is a really generous word for what it was. It was just a process we didn't touch, and it got the job done. And that makes it really hard to turn it into something like Lambdas that require little bite-sized functionality, and it makes it really hard to turn it into services if you just don't know what's happening in the middle of this process. And that's kind of where Step Functions comes in for us. So Step Functions got announced roughly December last year at Amazon's reInvent conference. And it's essentially a system for building workflows. Building flowcharts is another way to say the same thing. And you can view it a little cheekily as pretty diagrams as a service. So this is one of the example workflows that Amazon gives on their website. They have a whole bunch of them. But essentially, you've got a start to a process. You've got maybe a variety of ways to end the process. And you work your way through some sort of series of steps in the middle. Thus, step functions. Ignore the confusing connotations from math or EE if you're from that world. So there's a bunch of stuff you can build on it. This example right here is monitoring the status of a report. So you start a job and you wait a while for it to finish, and then you do any final actions. You can write a whole lot of different state machines. Essentially, you're just connecting these boxes in different ways and drawing whatever diagram of the business process you want to put into practice. And we've built some pretty complicated ones dealing with kind of buying stuff at Yelp. It turns out that buying stuff is a complicated process. It's got a whole bunch of interdependencies, and modeling it is pretty complicated. But the interaction is really simple. You essentially write down a state machine in a JSON DSL. So you're saying these states exist. They're connected in these particular ways. You write in some behaviors there, and then Amazon generates this pretty little diagram for you. So I don't make these diagrams. The UI is nice enough to do it for me. And our job, once we generate that state machine, is to implement functionality within it. So there's this concept called an activity task, which is basically just where you do something. And I give it a nice name, like create guest user. And Amazon says, you need to go ahead and implement whatever it means to create a guest user. Amazon doesn't have any clue. So it'll let us do this in two ways. We can either write a local process that communicates over APIs and says, hey, give me some work. I will do whatever I need to do. Maybe it's writing to a database, maybe it's sending an email, who knows. And then I'll tell Amazon, hey, I finished it, keep going with whatever that state machine was. And we can also write these as Amazon Lambdas. So whichever one is more appropriate for your use case, Step Functions does not care. And there's a lot of really cool behavior built into Step Functions. So we can have retry behavior kind of written into that state machine language we described. We can say, hey, please try to create a guest user 3 times. You're only allowed to spend 5 seconds every time. And if all of that fails, go ahead and transition to some sort of other step. So you can build this kind of logic into your flow. And there's a whole lot more depth and complexity there as well. So if you want to know the details, there's some really good docs online. I won't go into all of the different options you have, but there are quite a few of them. So back to the promised future. We have this old subscription billing process. We want to make it better. We want to be able to use these nicer technologies in the future. How is Step Functions helping me refactor this, helping me push in that direction? So we said we had this business critical process, and we said it kind of lived in the sequence of 3 jobs. And what we decided to do is just take the first of those steps, billing of accounts, deciding what people owe, and we were going to move that onto step functions for starters. Unfortunately, scoping it down to just billing of accounts didn't actually solve our problem. That didn't magically make this easy to do. It turns out that that big box of functionality was written a long time ago, had gotten modified and grown organically over those 10 years, and so it was kind of still a bit complicated. And we didn't really know what was going on inside of it. So if we changed it and broke it, we might not have any feedback to tell us, hey, Scott, you're in trouble, you need to go reverse whatever you just did. And it also had a lot of old kind of complex logic. So Python, its greatest skill is not concurrency. And over the years, we had had problems with scaling this out. We said we processed 100,000 accounts a night. That can't take more than 24 hours, and ideally it takes a lot less than that. And so we had built out kind of a custom parallelism framework to make that possible. So very roughly, we took all the accounts we needed to bill, broke them into chunks, and farmed out the work to other individual processes. And we needed to start from here and turn this into a workflow of some sort. So what we did was we took that high-level goal, bill all the accounts, and instead of breaking it into chunks, we said we're just going to have each individual account's job, billing one account in detail, be farmed out to a step functions workflow. So we're going to essentially make bill one account our workflow and do a bunch of these in parallel. And even though this is, you can see it right here, this is a really trivial flowchart, right? Turns out it has one state. It is all of the code we already had. If you look back at our example here, down at the bottom we have that bill account method that was in the old batch. We literally lifted it out and put it in the middle of a workflow as a single step. But we get to act like we're a service now. And this is something that we didn't have an API before, right? We didn't have an interface. I couldn't change the interface. Like really basic stuff we get from just moving into this single step workflow. And I talked earlier about getting to use Lambdas, and we still want to think about that in the future, but when we started, we were able to use these activity task API-driven workflows, and we essentially just talked back and forth with Amazon over their APIs to get work and tell that we had succeeded. So this is really basic. We built one step in a workflow. We didn't refactor very much at all, but we still got benefits from it. One really big problem that we solved was parallelism. So we talked earlier about our own kind of internal concurrency framework, and it was okay. But when we moved over to sort of using step functions to organize this parallelism, we actually saw a big boost here. So top graph, don't worry about the axes. Top graph is number of workers simultaneously operating in the old system. So you can see, this is over the course of the entire run of billing. At the start, we had a really high concurrency, and then pretty quickly, you see it starting to degrade over time, right? We're not keeping up, we're not really staying highly parallel. In contrast, when we turned on this workflow in step functions and we fired off a ton of these in parallel, Amazon did a phenomenal job running a lot of them in parallel. Turns out Amazon's pretty good at scale, pretty good at doing this stuff really well, and they were just fundamentally way better at it than we were. So right off the bat, we got this boost in sort of the efficiency or the utilization of the parallelism. And we also got really flexible timeouts. So one problem we had is our old process could get slow. It could get slow for every single account, and then 24 hours later, we would be 10% through our day, and we'd say, oh, what happened? That was unfortunate, right? We want fast feedback when stuff is slowing down, and we want to get yelled at really quickly. So we can put in these timeouts, and we can say this activity needs to take no more than 20 minutes. We can put in little heartbeats, and we can say, if I don't check in with you every minute, something is going wrong. Please don't wait 20 minutes to tell me that the whole thing is screwed up. And there's really good flexible support for this. And we also got better observability. So I talked about that first workflow having just one step, right? Build a whole account, do all the stuff. But one of the first changes we made was to actually break out two use cases away from that and essentially decouple the error handling. So if things were going really well, that's awesome. We're going to have this handle success state that basically just tells us at Yelp, hey, it worked. And if things go poorly, we're going to have a handle failure state. And in the beginning, we didn't put any complexity into this. We're essentially just saying, let's represent the fact that it didn't go well. In the future, maybe we want to page somebody. Maybe we want to wake Scott up in the middle of the night and say, hey, you need to go look at something, it's broken. But for now, we're just going to literally have a state that says a thing is going wrong in one particular workflow, so we can keep track of it. And one really benefit here is we can say, no matter what happens here, whether a thing went well or a thing went poorly, the state machine shouldn't die in the middle of it, right? I'm explicitly representing failure here in a way that should, theoretically, be cleanly handled. And if we can automate what to do in the case of failure, the account itself can still get billed in a consistent way, if not a finally successful way. And for us, when we're handling money, being able to be consistent is worth a tremendous amount. So benefits here. We get really safe refactoring now. So when we take that middle bill account step and we say, I wish that this were more parallel, Amazon Step Functions has an ability to run things in parallel. We can break apart one big task into 3 parallel tasks. I'm not handling any parallelism, any joining, any waiting for completion, which I love doing because it's hard. And instead, I get to focus on writing really bite-sized functionality in here. And so that kind of brings us to what this has to do with building towards serverless. One of the things that we really found was wonderful is Step Functions isn't very opinionated on how my architecture looks. It's happy to support me if I want to write a workflow with one activity, and Step Functions isn't going to judge me or not run if I'm just running a ton of code inside of one activity for 20 minutes at a time. But as I sort of refactor my own system, as I get ready to move towards a more bite-sized, more decoupled future, it's there to keep up with us. And in the meantime, it's providing some really valuable stuff even before I'm in this decoupled serverless microservices future. So it's got a lot of ability to add parallelism. It's really segmenting my work into different activities that can't talk to each other except through the step function itself. And we get this observability of any errors or of how the system is working. And that strong foundation for the future experimentation is what we've gotten really excited about. So again, just running through the history of what we just described, we started out with one big function doing all the stuff, and that was where we were when we began. And we put it into a workflow, right? And the workflow did all the stuff in one big function. No big changes here. And we started to decouple it. So we took out that error handling. We made ourselves aware of the success and failure and the difference between the 2 cases so that we could write code that handled them explicitly. And we started to do this refactoring more aggressively over time. So we were able to say, hey, let's break out a parallel state because we think we can. We think it'll make individual functionality more targeted and to the point. So I can write something that just knows how to do bookkeeping for the upgrades product versus the ad campaign product versus something else, and all my code gets dumber in the process. And then kind of longer term, we get to do this sort of directional, if we think serverless is the right answer, if we think Lambda is something that's relevant to us, Step Functions is happy for us to make individual activities Lambda functions instead. So this is nice from my perspective because I don't want to rush into these kinds of things. I want to be ready for it and decide it's the right choice. Step Functions will support us, whether we're all on these API-driven, sort of older school batch jobs, or if we want to go ahead and try one Lambda function or a few Lambda functions where we think they're appropriate. Either way, the framework still works. And so that's sort of where we ended up, and I'm hopeful that wherever your current system or project or what have you may be, this can be kind of a more realistic method for you to get from where you are today to some sort of serverless or microservice future. So that's all I've got. I'm really happy to talk about any of this more, either now in questions or after this in the hallway or something like that. Yelp itself has a bunch of engineering blogs and code out there. If you want to talk about any of that or what it's like to work at Yelp in general, happy to do that as well. Thanks. Yes, question.
So from an infrastructure standpoint, were you on Amazon prior to this transformation, or were you your own infrastructure environment?
Yeah, so were we on Amazon prior to this project, or was this sort of the first step in that direction? Anything in particular you're thinking of when you say on Amazon? Or?
Yeah, no, so where I'm coming from is that was this a cloud transformation project or was it already there?
Yeah, so Yelp in general has been, I would say, directionally moving toward more Amazon use over time for I've been at Yelp 6 years, and I think basically that whole time we've been directionally moving more and more in that direction. So this is by no means the first time we've used an Amazon service. We are not only on Amazon like EC2 or web servers for the sake of actually serving traffic, but we're certainly a majority there. Step Functions itself doesn't actually care, which is kind of nice. So because it'll let you work over APIs like that, if I'm running out of my own, if I'm running out of my like upstairs computer jacked into the internet, like it will be happy to take jobs from that server physically hosted in my house, or it can do stuff from an Amazon EC2 instance. It really is not very opinionated. Yeah. And I think like that's frankly what was very attractive to us, right? We didn't want to have to wait until we were sort of had our house perfectly in order to move toward these directions. And the sort of it'll accept you where you are and give you tools to get where you want to be is what made us so excited about it.
Yeah, so what I'm envisioning is a hybrid where you can leverage Amazon functions but not have to completely transform the app to refactoring and all that.
Yep, exactly, yeah. Cool. Sure.
Yeah. So you talk about one of the problems you have with the previous version of the workers, that all the workers are not being utilized like completely. Yeah. Why do you think that was the case before?
Yeah, we showed this graph of previous utilization over time. And the question is sort of why, right? Why was Step Functions so much more effective at this? A lot of this comes down to just the question of managing parallel work. If I give you 10 jobs to do and I say, check back in with me when one of you needs a new job, that's a hard problem. Like really non-trivial stuff. Python with multiprocessing and tools like this has ways of helping you do this, but you're still rolling a lot of it yourself. In effect, Amazon is just sitting up in the cloud, and we're shoving work at them, and we're trusting them to keep track of it. So the way we actually run this, the reason that curve is so smooth is we have an initiator batch, something that's starting these workflows. It's shoving work at Amazon as fast as it can. It's got a fixed parallelism, and it's just doing nothing but submitting work. And Amazon, unsurprisingly, can scale up to that. So as long as we have enough of those activity batches keeping up with the tasks, it'll look pretty much like this. So yeah, it's really a question of the scale and ability for us not to implement all the hard parts. Yeah. Yes?
What's Amazon's cost model for the Step Functions feature?
Ooh, cost model. The cost model for its precursor, Simple Workflow, is complicated. The cost model for Step Functions is really, really simple. So if I go to something kind of complicated, every time I transition in this diagram, I pay a fixed cost. So I'm going to screw up the number. It is extremely cheap. I'm going to say, look it up online, but I think it's like 25 cents per 1,000 or 10,000. It's really cheap. Yeah, don't quote me on that. I'll put it on Twitter or Slack after I look it up. But very, very cheap. Sorry?
It's 2.5 cents per 1,000.
2.5 cents per 1,000, yeah. So that's a good deal and really simple, right? So the only quirk there is if I do retries or anything like that, that's a state transition. So it's possible for you to have a decent amount of cost there, but it's pretty reasonable and it's dead simple, which is nice.
You didn't find yourself designing the FSM around the cost?
We haven't yet found ourselves designing FSMs around cost. I'm sure that if I went hog wild on a really complicated state machine, somebody would follow up with me about that. So far we've had